Hello and welcome back to another video. In this video we are going to solve the question number 8th, 9th, 10th from the October-November 2019 9709 paper 3-1, that is pure mathematics 3. So here's the question number 8. Let fx be x square plus x plus 6 over x square into x plus 2, and the first part is to express the fx in partial fractions. It is of 5 marks. We need to express first of all in the partial fraction. So I'll write this equation here. So here we can see it is power 2 x square. So one thing, for one first constant we'll take a over x and then b over the same thing with the x square, and the lastly for this bracket, and it is going to be x c over x plus 2. And now we need to find the value of a, b and c, and we'll put it here, and that is going to be the partial fractions. So first of all, let's multiply the whole equation by x square into x plus 2, and we will get the left hand side would be only x square plus x plus 6, and right hand side would be a into x times x plus 2 plus b times x plus 2. I'm multiplying the whole equation by this denominator, and plus c times x square. Now we'll substitute the values of a value. This is true for all the x, so I can put any value in place of x. So I'll put x is equal to 0 first of all. So I'll get this as 6, this is 0, so it is 2b. So from here we will get b is equal to 3. Now we'll replace x is equal to minus 2, because I would say earlier I get rid of x, c and a, because this was x. So if it is 0, it would be completely vanished. So I need to get rid of this a and b this time. So I'll put x is equal to minus 2. So if we put x is equal to minus 2, it would be 4 minus 2 plus 6, and which is going to be 2 plus 6, 8. And the right hand side would be, this is 0, this is 0, and it is 4 into c, so it is 4c. So you got from here c is equal to 2. So now we got b, we got c. Now we need to find a value, since it is again true for all the values, so I can put any value. I'll put x is equal to 1. We should always choose the value which is very easy to calculate. So if it is 1, so 1 plus 6, that is going to be 8, is equal to a into 1 plus into 1 plus 2, 3, so it is going to be 3a, and 1 plus 2, 3, so it is going to be 3b, and plus c. So now we will replace the values of this b and c here, and we will get it as 8 is equal to 3a plus 3 3s are 9 plus 2. So it is 11 minus 8, because it will go that side. So minus 11 plus 8 is minus 3. So we will get 3a is equal to minus 3, or we can say a is equal to minus 1. So as we got a, b and c value, the partial fraction of this is going to be fx. I'll write fx in place of this whole equation as minus 1 over x plus 3 over x square plus 2 over x plus 2. So that is the final answer for this. I hope it is okay. Let's do the next part of this 8th question. Second part is, hence showing full working, show that exact value of integration from 1 to 4 fx dx is 9 by 4. So we have fx now as minus 1 over x plus 3 over x square and plus 2 over x plus 2. So if we do the integration, it means we are going to do the integration of all from 1 to 4. Let's integrate it. It is going to be 1 to 4 minus 1 over x, so it is ln ln x, and it is minus, plus 3 times it would be x to the power minus 2, so the integration x to the power minus 2 plus 1 minus 1 divide by minus 1, plus it is going to be 2 times ln x plus 2. Will not apply modulus because in between 1 and 4 this is not going to be negative, and then we'll put the limits from 1 to 4. It is going to be minus ln 4 minus, it is 3, so it is minus 3 over x, that is 4, plus 2 times ln 4 plus 2 6, and minus the low, this by putting the lower limits, that is going to be 1, so ln 1 minus 3 over 1 plus 2 times ln 1 plus 2, that is 3. So we got it as minus ln 4, so minus ln 4 minus 3 by 4 plus ln 36, because it is 2 so it would go here in the power, so it would be 36 x square 6 square minus minus plus, that is going to be 0 because ln 1 is 0, plus 3, and it is minus 2 times ln 3, so minus 2 times ln 3 is minus ln 9 because 2 will go in the power. Now we are going to collect it. 3 minus 3 by 4 is going to be 3, 4 3 are 12, minus 3 9 by 4, is going to be 4 into 9, so it is also going to be 1, at the last you will get 9 by 4. That's the answer. The exact value is 9 by 4. So I hope it is clear. Let's do the next question. Here's the ninth question. First part, by first expanding cos 2x plus x, show that cos of 3x is equivalent to 4 cos cube x minus 3 cos x. So first of all, let me write what is the expansion of cos a plus b. It is cos of a cos of b minus sine of a sine of b. So we'll substitute the value and we'll get cos of 3x as cos of 2x plus x, and hence cos of 2x into cos of x minus now we will use the double angle of cos and sine, and double angle of cos in terms of cos only because there is no sine, and that is going to be 2 times cos square x minus 1 into cos x minus double angle of sine is 2 times sine x cos x into sine x. So we got it as 2 times cos cube x minus cos x. Sin x into sin x is sin square x, so I'll change this in the 1 minus cos square x, so 1 minus cos square x. This is at the place of sin square x. Now again let's expand it, so it is going to be 2 times cos cube x minus cos x minus 2 cos x minus minus plus 2 cos cube x, and finally we'll collect it and we'll get this as equivalent to 4 times cos cube x minus 3 times cos x. That's the proof. I hope it is clear. Let's do the next part of it. Second part is, hence solve the equation cos 3x plus 3 cos x plus 1 is equal to 0 within 0 and pi. So first of all, we'll replace this cos 3x by 4 cos cube x minus 3 cos x plus 3 cos x already given plus 1 is equal to 0. So we can see these two got cancelled and we got it as cos cube x as minus 1 over 4. So cos cube x is minus 1 over 4. So from here we will get cos x directly by taking cube root of it. So cos x is going to be cube root of minus 1 by 4, and remember this is not the imaginary value, it is cube root. In the square root it was imaginary value, so x will be cos inverse of root of minus 1 by 4. So let's calculate by calculator. In radian from the calculator, sorry, it is cube root. In radian from calculator it is coming 2.25 radian. For the other values, we know that if we for the cosine it is going to be 360, that is 2 pi minus 2.25, that would not fall in this range. So this is the only solution for this equation. So that's the solution for it. Let's do the next question. Third part of this is find the exact value of integration from pi over 6 to pi by 3 cos cube x dx. So as such we don't know the formula for cos cube x, but we know that cos cube x comes in the expansion of cos 3x, which we have done in the first part. So I'll write cos 3x is equal to 4 times cos cube x minus 3 cos x. So from here we can find the value of cos cube x, and that is going to be 1 over 4 times 3 cos x plus cos 3x. So I'll replace this value, I'll substitute this value in the given question, and I'll get this integration as I'll write I as 1 over 4 times integration of first function, that is going to be 3 cos x dx from pi by 6 to pi by 4, of course, pi by 6 to pi by 3, sorry, plus 1 over 4, because 1 over 4 is multiplied everywhere in both the terms. So it is going to be again from pi by 6 to pi by 3 and cos of 3x dx. So now it is going to be the integration. So it is 3 by 4 cos x integration is sin x, not minus sin x, sin x only. So it is going to be sin x from pi by 6 to pi by 3 plus it is going to be 1 upon 4 integration of cos 3x is minus sin 3x upon 3, because the differentiation of 3x will also be divided, and then put the limits from pi by 6 to pi by 3. It is going to be 3 by 4, the upper limit sin pi by 3, that is root 3 over 2, minus lower limit, that is pi by 6, sin pi by 6 is 1 over 2, plus 1 by 4 3 are 12, upper limit is pi by 3, so sin pi by 3 into 3 is sin pi is 0, minus sin 3 into pi by 6 into 3 is pi by 2, and pi by 2 it is 1. So the final answer is going to be 3 by it is 2, 4 2s are 8, and root 3 minus 1 and minus 1 over 12 from the second bracket. So we can calculate it, and we can write the last answer as it is coming as minus 11 from calculator, minus 11 plus 9 over root 3 upon 24. We can write it separately, and since they have asked for exact value, so we are not going to write in the decimal, so we can write minus 11 over 24 plus 9 over 24 root 3. We can cancel this also, but it's not required. That is the final answer. So let's do the last question of this paper. 10th A part, the complex number u is given by u is equal to minus 3 minus 2 root 10 iota. Showing all necessary working and without using a calculator, find the square roots of u. Give your answer in the form of a plus iota b. where the numbers a and b are real and exact. So for instance, if we know that 2 is a square root of 4. How? Because if we do the 2 square, we get 4. Similarly, let u be a plus iota b be the square root of this. So if it is the square root of this, it means if we'll do the square of it, we will get minus 3 minus 2 root 10 iota. And here a and b are real and exact. So we'll do the square of this and we'll get a square plus iota b whole square plus 2 times a b iota is equal to minus 3 minus 2 root 10 iota. And since we know that iota square is minus 1, so we will get it from here as a square minus b square is plus 2ab iota is equal to minus 3 minus 2 root 10 iota. So if we compare the real parts and imaginary part, we will get it from here that a square minus b square is equal to minus 3 and 2ab is equal to 2 root 10. So if we'll cancel it, we'll get a into b is root 10. It means we are going to take a or b from here. I'll take a from here as root 10 over b. And now we are going to substitute in this value and we will get it as sorry, it was minus this because it is minus b square minus b square is equal to minus 3. Now if I multiply this equation, whole equation by b square, we will get it as 10 minus b power 4 is equal to minus 3 times b square. I have multiplied everywhere. This is only got cancelled, otherwise we have multiplied and use the law of indices. So I'll take this everything to the right hand side. So it becomes b power 4 minus 3b square minus 10 is equal to 0. So now we can see it is like if we multiply two number, we'll get 10, and it is a quadratic in b square. It is a biquadratic in b, so it is quadratic in b square. So I can write in the fact I can factorize it as b square. We know it is going to be 5 and 2. When you multiply, you will get 10, and if you subtract, we get 3 minus 3. So it would be b square minus 5 into b square plus 2 is equal to 0. So from here we will get b square as 5 or minus 2, and since b and a are real number and exact real values, so it is not possible that you will get a square of a real number as negative value. So it is not possible. So only possible values for b is going to be b square is equal to 5. So from here we got b square is equal to 5 or b is equal to plus minus root 5. So we will put it in this and get the value of at 2. So 1 square root of this is going to be u is equal to minus root 2, that is a, plus root 5 iota, and another we will get at b is equal to minus root 5, and it is going to be a is equal to minus root 10 over root 5, which minus got cancelled, and we got it as only root 2. So another square root is going to be u is equal to root 2 minus root 5 iota. So these are the two square roots of the equation of u is equal to -3 -2 root 10 iota. So I hope it is clear. Let's do the last question of this paper. Here's the B part. On a sketch of an argand diagram, shade the region whose points represents complex number z satisfying the inequalities this, this and this, where imaginary of z denotes the imaginary part of the complex number z. So first of all, we know if it is modulus of z minus 3 minus iota is less than, or let's say equal to 3, it denotes a circle. I can make it as z minus 3 plus iota is less than or equal to 3. So center is 3 comma 1, and the next one is argument of z, and it is going to be the half line. It is going to be the half line from z, that is z minus 0. So from origin it is a half line, and the argument, it is going to be more than pi by 4, so it would be more than pi by 4, the upper part of it. And imaginary of z is the on y axis, where it is going to intersect at 2. So let's draw it. So it is 3 1, so let's say this point is 3 1 2 3 and 1, and the radius is less than or equal to 3, so we can have the circle here with the center 3 comma 1, and the line y, imaginary y is equal to 2 here. This is y is equal to 2 line, and this is a circle with center 3 comma 1, and then the half line from origin to the, so now we got points. I'll mark point. It is going to be 3 comma 1, so it would be 1, and this is 2, so this is a line imaginary is equal to 2, imaginary of z is equal to 2. So collectively, if you'll shade it, we'll get it as this region. This is the region, because it is in the circle, inside the circle, so it is, that's why z modulus of z minus 3 minus iota is less than 3, and it is greater than imaginary of 2. Imaginary value of z is greater than 2, and half line is more than, making angle more than pi by 4. So this was pi by 4, it is pi by 4, so this is more than pi by 4, this is more than 2, and the circle, it is lying between the, within the circle. So that is the sketch on the of an argand diagram. So I hope it is clear. That's the last question of this paper. I hope it was helpful. Thank you so much. See you in the next video.